Alright, we're going to start with a warm-up, and you can pause the video. I'm just going to write in the answers. So in the warm-up, you're supposed to decide if the triangles are similar, and if they are, then write a similarity statement and the postulate or theorem that justifies it. Alright, here's some new vocabulary for this section. So you may want to have out your vocabulary. You may just want to follow along however you need to. Here's the first one, triangle proportionality theorem, which says if you have these two pairs of parallel lines, TU and QS, then inside of a triangle, it creates some sides and some ratios in the triangle. So you can know that RT is proportional to TQ, and that ratio must be equal to RU over US. And we'll look at a few examples like that. Basically, those parallel lines make a lot of different ratios and proportions that are useful. And in the same way, you can go the other direction, the converse of the triangle proportionality theorem. If you know that you have these sides that are, ratios RT divided by TQ is equal to RU divided by US, then you can know that those lines TU and QS are parallel. All right, here's another one. And you can stop the video and write these down in your vocab if you want. It says if there are three parallel lines that intersect two transversals, then they divide the transversals proportionally. So if R is parallel to S and S is parallel to T, then you can know that there's all these kinds of proportions, that UW is proportional to V, or WY, I guess, and then that ratio is equal to VX divided by XZ. All kinds of proportions when you have these parallel lines. And then this last one's probably the most weird or confusing, but it's really not that bad. It says if a ray bisects an angle of a triangle, then it divides the opposite sides into segments whose lengths are proportional to the lengths of the other two sides. So if you see you've got these two markings here in a triangle, let's say, we're going to see a few examples, you know that your ray bisects the angle. Then it creates a lot of proportions, just like the parallel lines did. We can know that AD divided by BD is the same ratio as CA divided by CB. So you'll use that. You'll use all of these today. Okay, it's not working. All right, let's look at our first example. So here we have a bunch of parallel lines, and we're going to use our proportions in these parallel lines. So in my triangle, I have BD is parallel to AE, which means that 10 divided by 5 must equal 7 divided by x, looking at what we just saw. So if you do some math, x is 3.5. Part B here is the same situation. It's a little bit different because what they're giving you is this length of the whole side here. So what I'm going to do, this length is 50. What I'm going to do is I'm going to find the length of the other whole side, and then I'm going to set up a proportion that way, which is 45. So what I'm going to say is that I know 20 is to x just like 45 is to 50. That's a completely appropriate proportion to set up, but again, there's probably several others you could set up. X turns out to be 200 over 9. And then the last one, I'm going to do something similar as I did in part B. I can see that this whole side right here is 18, and I've got my other side MP being 23. So what I can do is I can say that 7 is to 18, this portion right here, is to 18, just like x is to 23, and x is that sort of corresponding part on the other side of the triangle. So when you do that, x is 161 over 18. Now in the problem they want you to find the value of all the variables, so we're actually going to have to put x back in here. We know that whole length MP is 23. So to find y, we're going to need to just do a little bit more math. So y is 23 minus 161 over 18, which is 253 over 18. All right, let's look at the parallel lines and transversals here next. So in this diagram, we know that 1 is congruent to 2 and 2 is congruent to 3, these angles here. So what I can know for sure, 1 and 2 are corresponding. So that means I can say for sure that AB, AD is parallel to BE. I also can see that 2 is corresponding with 3, and those are congruent. So I can also say that BE is parallel to CF. Okay, so I have these 3 pairs of parallel lines, and the reason why I can say this is from a while ago, but by the corresponding angles converse. Anytime you want to prove parallel lines, it's the converse. Okay, so now they want us to solve for x, and if you remember from our vocab earlier, these parallel lines create all kinds of ratios in this figure. One proportion that is true is that 6 must be proportional to x, just like 9 is proportional to 8. You could have also done x divided by 8 is equal to 6 divided by 9. There are others of you that would do it differently. Again, more than one way. So x turns out to be 16 over 3. All right, last one. Okay, this is using our last new vocabulary, which was maybe the most challenging, but just look back at your vocab. I can even glance back here. Let's look at the very last one. You've got a ray that bisects the angles, which says something about the ratio of these segments here. AD is proportional to DB, just like CA is proportional to BC. Okay, so we're going to use that. So here I've got this ray that bisects this angle. Good. So I know that 12 is proportional to A, just like 22 is proportional to this 12 here. Okay, so one more time, let me walk through where I got all these numbers. This 12 I'm getting from this side here, and this A I'm getting from here. And then this 22 here I'm getting from here. And then this 12 I'm getting from here. All right, so cross multiply, do some math. A is 72 over 11. All right, let's look at this one. So I can see that there's a number of different ways to approach this, but what I'm going to do is I'm going to say that 5 here is proportional to x, which is this x right here, just like 8 is proportional to, and then this part right here is going to be 7 minus x, because the whole length of BD is 7. So just like 8 is proportional to 7 minus x. Okay, so cross multiply. 5 times this whole quantity. Make sure you don't forget that. There are still people forgetting that. Distribute 35 minus 5x equals 8x. Add 5x to both sides. 13x equals 35. And then you can just divide. All right, so I can go over more of these tomorrow. If I were you, I would stop the video and fill out the vocabulary.